My name is Muhammad Afiq bin Muhammad Hairi, number matric AA191054. Okay, let me tell about bipolar junction transistor, BJT. Introduction to BJT. A bipolar junction transistor is a three-terminal semiconductor device consisting of two PNP junctions which are able to amplify or magnify a signal. It is a current controller device. The three terminals of the BJT are the base, the collector, and the emitter. There are two types of bipolar junction transistor, which is NPN transistor and PNP transistor. The 2N3708 is manufactured in a plastic TO92 case. When looking at the flat side with the lead pointed downward, the three leads emerging from the transistor are from left to right: the emitter, collector, and the base lead. Okay, next. Type of BJT. Okay, firstly, NPN. NPN, negative, positive, negative, is a type of BJT where a p-doped layer of semiconductor exists between the two layers of n-doped material. The p-doped region represents the base of the transistor, while other two layers represent emitter and collector respectively. NPN transistors are also called minority carrier devices because minority charge carriers at the base side are used to control large current at other terminals of the transistor. The current moves from an emitter to the collector, where electrons act as a minority carrier at the base side. Okay, the second, PNP. PNP, positive, negative, positive transistor, is a type of BJT where n-doped semiconductor layer which acts as a base. It houses between the two layers of p-doped material. The base uses small base current and negative base voltage to control large current at the emitter and collector side, and voltage at the collector side are larger than the voltage at the base side. In PNP transistor, current direction and voltage polarities are reversed as compared to NPN transistor. And PNP transistor work in a similar way like NPN transistor with some expectation. Holes are diffused through the base from an emitter and the end collector by the collector. The transistor is rarely used for application as conduction carried out by the movement of electrons is considered fast and hold more volume as conducting by movement of hole. Okay, this is characteristic of the 2N3708 bipolar transistor. Material of transistor is silicon. Polarity is NPN. Maximum collector power dissipation is 0.36 volt. Maximum collector base voltage is 30 volt. Maximum collector emitter voltage is 30 volt. Maximum emitter base voltage is 6 volt. Maximum collector current is 0.03 ampere. Max operating junction temperature is 150 Celsius. Transition frequency is 100 MHz. Collector capacitance is 11 picofarad. Forward current transfer ratio is 45. Noise figure is none. Package 20992. Pros of BJTs. Bipolar junction transistor come with a large amplification factor. This type of transistor provide a better voltage gain. The transistor come with a capability of operating in 4 regions: active region, reverse mode, saturation, and cut-off region. BJT provide a better response at a higher frequency. BJTs also act as a switch. And last one is cons of BJTs. BJT is very sensitive to heat and produce noise in some cases. The switching power of BJTs is very low as compared to unipolar transistor like FETs. Okay, that's all from me. Thank you.
Assalamualaikum, my name is Ahmad Renan bin Abu Bakar. My matrix number is AA190659. So now I'm going to talk about the JFET. So we move on to the introduction. The junction gate field effect transistor JFET is one of the simplest types of field effect transistor. JFETs are three-terminal semiconductor devices that can be used as electronically controlled switches or resistors or to build amplifier. Unlike bipolar junction transistors, JFETs are exclusive voltage control in that they do not need a biasing current. Electric charge flows through a semiconducting channel between source and drain terminals. By applying a reverse bias voltage to a gate terminal, the channel is pinched so that the electric current is impeded or switched off completely. Next, we move on to the structure of JFET. JFET is the simplest form of FET transistor and it has three terminals. The JFET transistors are classified into two types. They are N-channel JFET and P-channel JFET. In the N-channel JFET, the channel is doped with donor impurities. Due to this, the current passing through the channel is negative. But in the P-channel JFETs, the channel is doped with the acceptor impurities. Due to this, the current flowing through this channel is positive. The N-channel JFET has more current in conduction than P-channel JFET because the mobility of electrons is greater than the mobility of holes. So the N-channel JFETs are widely used than P-channel JFETs. The small voltage at the gate G terminal controls the current flows in the channel between drain and source of the JFET. And now we're going to talk about the JFET operation. JFET will operate under three conditions. The first one is no voltage. When neither any voltage is applied across source to drain terminal, nor any bias is applied to the gate terminal, the depletion region around the P-N junction are of equal thickness and symmetrical in nature. The second condition is negative voltage. When the gate is negative bias with respect to the source and drain is applied with a positive bias with respect to the source, the P-N junction got reverse bias and forms depletion region. And the last condition is positive voltage. When a positive voltage is applied to the drain terminal with respect to source terminal without connecting the gate terminal to the supply, the electrons start moving from source terminal to drain terminal, whereas conventional drain current ID flows through the channel from drain to the source. Next is JFET configuration. So JFET has three configurations, and the first one is common source configuration. This is the most common mode of operation of the FET due to its high input impedance and good voltage application, and as such common source amplifier are widely used. The common source mode of FET connection is generally used audio frequency amplifier and in high input impedance preamps and stage. The second one is common gate configuration. The high input impedance feature of the previous connection is lost in this configuration as the common gate has a low input impedance but a high output impedance. This type of FET configuration can be used in high frequency circuits or in impedance matching circuits where a low input impedance need to be matched to a high output impedance. And the last one is common drain configuration. The common drain or source follower configuration has high input impedance and a low output impedance and near unity voltage gain, so is therefore used in buffer amplifier. The voltage gain of the source follower configuration is less than unity and the output signal is in phase with the input signal. So the type of JFET we chose for this project is 2N3687, and as you can see on the left side, It is the datasheet of the amplifier, of the JFET amplifier, which is 2N3687. So I guess that's all for my part. Thank you.
Rahim. Okay, here is the comparison between BJT and JFETs. So I have made a table to make it easy to compare the here parameters. So first of all, uh, they also have a own symbol for the electronic symbol here. Here is for BJT. Yeah, this is collector, base and emitter, and here is JFETs. So next is definition. What is BJT? BJT is known as bipolar junction device because it uses both electrons and holes for conduction. And the definition for JFET is unipolar device because current is due to one charge carriers, either electrons or holes. Okay, next for the input resistance, BJT offer low input resistance while JFETs offer large input resistance order to 1 mega ohm to 5 mega ohm. So next is biasing use. Okay, of course BJT fixed bias, collector base bias, voltage divider biasing, while the JFETs have bias and voltage divider biasing. For the operating region, BJT is active, saturation and cut-off region, and the JFET is ohmic and pitch-off region. So the thermal runaway occurs at high temperatures. For the JFETs, no thermal runaway. And type of device that BJT is current control device and JFET is voltage control device. And the terminals for the BJT base emitter and collector as shown as here in this figure, base, collector, emitter, and for the JFET gate drain source, yeah, as shown here, gate drain source. And the input current for BJT is order of milliampere, and while the gate current is order of nanoampere, smaller than BJT. So what the application for BJT? Okay. BJT are used for in low current application, while the JFETs is also low. Not also JFET using low voltage application. So here the other application for BJT. Here is the application for BJT JFETs. Okay, BJT. The main basic function of a BJT is to amplify current. It will allow BJTs are used as amplifiers, or switches to produce wide applicability in electronic equipment, include mobile phones, industrial control, television and radio transmitter. Okay, for the effects, the junction field effect transistor of or JFET is widely used in electronic circuit. Yes, of course. The junction field effect transistor is a reliable and useful electronic component that can be used very easily in a variety of electronic circuits, ranging from JFET amplifier to JFET switch circuit. Yes. Okay, this is the other application for BJT. Okay, first is the bipolar junction transistor is used in logic circuit. Second, the BJT is used as a oscillator. Next, it is used as amplifier, of course. Then it is used as multi-vibrator. Next, for wave shaping, it is used in clipping circuit. Yeah, of course. Used as a detector or demodulator. And next, it also used as modulator. Used in a timer and time delay circuit. Also used in electronic switch and switching circuit. For the JFETs, JFET is used as a switch as a chopper, as an amplifier, as a buffer. Also, JFET also used in the oscillatory circuits because of its low frequency drift. That's a It used digital circuits such as computer, LCD, and memory circuit because of their small size. And then in communication equipment such as FM and TV receiver because of their low modulation distortion. Yes, of course. And as a voltage control resistor in operational amplifier. And last is JFETs used in cascade amplifiers and in RF amplifier. Okay, here is the example of BJT. Our BJT coding, the code is 2N3708. Okay, this is the voltage example for the voltage divider biasing. Okay, you can see in the figure here. Okay, here voltage divider bias configuration. Okay, Vs, of course Vs equal to R2 over R1 plus R2 times VCC. Okay, this is voltage divided by a circuit using Proteus. Okay, the formula that involved in BJT is V is equal to R2 over R1 plus R2 times VCC. VE equal to VB minus VBE. IE equal VE over RE. And IC approximately to IE. VCE equal to VCC minus IC. RC minus ICRE. Okay, here is example of JFETs for the voltage divided by C. This is the figure. That's a simple circuit. The voltage control device use Kirchhoff voltage equation. Negative VR2 minus VGS plus VRS equal to 0. VRS equal to VR2 plus VGS. Next, VRS equal to ID times RS, and ID times RS equal to VR2 plus VGS, and last is RS equal to VR2 plus VGS over ID. So this figure is for the voltage divided by circuit using Proteus. Here. Okay, that's all from me. I hope I can explain more details soon. Thank you.